A solution to a system of equations is a set of variable values that make each equation true. Most linear systems made up of two equations will have one solution, but there are other possibilities. Let's look at what the graphs of the different solution types look like. The type of system you've seen most often is one whose graph includes two lines with different slopes. A system like this will have one solution that corresponds to the coordinates of the point of intersection of the lines. A second possibility is that the two lines represented by the system are parallel. These lines never intersect, so there are no sets of coordinates that will satisfy both equations. This type of system does not have a solution. The third possibility is that the two lines represented by the system are the same line. These lines are said to be coincident. Each point on one line also lies on the second line, so any point on the line is a solution to the system. This type of system has an infinite number of solutions. Let's put these aside and look at some examples. Determine the number of solutions each system will have. The slope of the first line is 12. The slope of the second line is also 12. The slopes are the same, so the two lines will go the same direction. The first type of graph is no longer a possibility. Let's look at the y-intercept to decide between the other two graph types. The y-intercept of the first line is negative 155. The y-intercept of the second line is 180. The two y-intercepts are different, so the lines are not coincident. The third graph type is not a possibility. The two lines are parallel, so there is no solution to the system. Let's look at another example. The slope and y-intercept cannot easily be determined from these equations, so let's convert both to slope-intercept form so we can compare them. Subtract 3x and add 7 to both sides of the equation. Divide both sides of the equation by 5. The equation is now in slope-intercept form. Subtract 6x and 14 from both sides of the equation. Divide both sides of the equation by negative 10 and simplify. This equation is now in slope-intercept form. The slope of the first line is negative 3/5, and the slope of the second line is 3/5. The two slopes are different, so the two lines will intersect once. The system has one solution. Let's look at a third example. The slope of the first equation is 3, and the slope of the second equation is also 3. The slopes are the same, so the first type of graph is not a possibility. The y-intercept cannot be determined easily from the first equation, so let's rearrange it to slope-intercept form. Multiply the 3 through the brackets. 3 times x is 3x, 3 times 5 is 15. Add 1 to both sides of the equation. The equation is now in slope-intercept form. The y-intercept is 16 for both lines, so they are coincident. This system has an infinite number of solutions.